8 days before 3I Atlas makes its closest pass to Earth, a new image drops from Hubble. You see it in a headline or a reposted screenshot. A thin, bright streak with not one, but two distinct tails. One of them pointing almost back toward the sun, sharp as a knife. The caption says something like, "This is not a normal comet." A few days earlier, you might have seen a note from Japan's space agency. X-rays are coming from this object, as if invisible gas is colliding with the solar wind. And yet, other observatories are still reporting no sign of the usual comet gases at all. That is probably why you are here. You are not a teenager chasing clickbait. You are an adult man who has lived long enough to be skeptical, but still curious. For weeks, you have seen the name 3I Atlas popping up in your feed. You have heard people call it Interstellar, weird, unlike anything we've seen before. You have watched arguments play out. Some voices calm, some dramatic, some trying very hard not to say the words artificial object, and some shouting them in all caps. You have seen charts, orbits, long exposure photos that claim it is moving 76,000 kilometers in 18 minutes. You have read that it has no gas, and then, somehow, that it produces X-rays that require gas. Each new piece of information seems to cancel the last one. So when you see the title, 8 days left, is 3I Atlas a friendly visitor or serial killer sent to Earth? Science for sleep? You don't click because you think something is going to slam into the planet. You click because you are tired of half answers. You click because you want one calm, coherent story that pulls all of this together. You click because you are curious what those new clues, the Hubble image, the JUICE confirmation of twin tails, the X-ray detection, actually mean. And you click because you want to understand what, if anything, you should be watching for when the countdown reaches 0. Right now, 3I Atlas is far beyond the reach of your daily life. It is more than 170 million miles away, moving through the inner solar system at a speed your intuition cannot hold. It is not on a collision course with Earth. No serious astronomer is sitting in a dark room predicting impact scenarios. The serial killer in the title is not a literal threat. It is a reflection of a deeper question. Is this object chemically friendly, rich in the ingredients that build life, or chemically hostile, loaded with things that would tear life apart? Is it a gentle messenger from another stellar neighborhood, or a frozen capsule of lethal chemistry? And more importantly for you, what do those possibilities actually mean for our understanding of the universe? You are 8 days away from the moment when every major telescope that can see it will turn toward this one point of light. 8 days away from the clearest look humanity will get at an interstellar visitor that has already broken several of our rules. 8 days away from the night when some people will nervously refresh their news feeds for drama, while others quietly will look up and simply wonder. The question in your mind is simple. When that night comes, do you want to be one of the people repeating rumors, or one of the few who actually understand why this object matters? So here is what this story offers you tonight. In the next hour and a half, at a slow and steady pace designed not to jolt you awake, but to carry you towards sleep, you will hear how 3I Atlas was discovered, why its orbit proves it came from another star, and what makes it so chemically strange. You will hear about the 4 impossible behaviors that have been reported: a comet with no cometary gases, an object that stayed quiet until after perihelion, an X-ray source without obvious neutral gas, and a tail structure that seems to point the wrong way. You will learn why some scientists see these as natural but unusual, while others see them as hints of something we do not yet have language for. You will hear how the latest data, those Hubble images, the JUICE confirmations, the X-ray detections from JAXA, have changed the tone of the conversation in the last weeks. You will hear why someone like Avi Loeb is willing to say there is a significant chance this object is not purely natural, and why many of his colleagues push back hard against that idea. You will understand what mantling is, and why some astronomers think 3I Atlas may have sealed itself shut in a skin of carbon-rich dust, hiding whatever is still boiling inside. And you will get a clear, simple picture of the 3 main scenarios for what could happen when it reaches its closest point to Earth. Most importantly, you will learn what December 19th is really about. Not danger, not apocalypse, not the sky falling. You will learn what a silent outcome would mean, what a sudden brightening would mean, and what a boring photograph with fascinating invisible data would mean. You will know what to look for in headlines without being misled by language that is designed to scare or sell. You will know why, no matter how dramatic some thumbnails may get, the physics of this orbit does not permit a last-minute swerve toward Earth. All of this will be told to you in the second person, because this is not just a documentary about a comet. It is a conversation with you about your curiosity, your late-night questions, and the part of you that still feels small and awake when you think about the distances between stars. You are not being lectured at. You are being walked through a mystery, gently, step by step, at a pace your tired mind can handle. If you stay, you will come away with something most people will not have: a quiet, confident understanding of what is actually known about 3I Atlas, what is truly unknown, and what all of it says about the universe you live in. You will know why some people call it a friendly visitor, why others use darker metaphors, and why the truth is more interesting than either extreme. And when you finally close your eyes tonight, you will do so in a world that still has bills and emails and ordinary worries, but also, just beyond the edge of your atmosphere, a visitor older than your son, passing by, leaving you with more questions than fears. 8 days left, a new image on your screen, a handful of strange clues, and now a story to hold them all together while you rest. In the last 10 days, 3 major updates have changed the tone of everything scientists thought they understood about 3I Atlas. You may have already seen pieces of these updates scattered across social media, buried inside long astronomy threads, or reposted without context. But tonight, you're going to hear the full picture, calmly, clearly, and in one place. This is the part of the story you came for. The real, newest clues. The first update arrived on November 30th, when Hubble released its clearest image, yet using the Wide Field Camera 3. If you've seen that photograph circulating online, you know it doesn't look like the soft, fuzzy glow most comets produce. Instead, it looks structured, almost engineered by the physics inside it. 3 distinct features jump out instantly: a long dust tail reaching into deep space, a curved ion tail pushed by the solar wind, and a razor-straight anti-tail pointing nearly back toward the sun. That anti-tail is what made astronomers lean forward in their seats. It shouldn't look that sharp. It shouldn't look that rigid. And yet there it is, slicing through the darkness like a line drawn with intention. Around the nucleus, Hubble picked up a tear-shaped coma, brighter on one side, dimmer on the other, lopsided in a way that hints at uneven heating or internal vents that only activate on certain faces. A normal comet forms a round cloud. This one forms a shape. You don't need to memorize any of the technical details. You only need to hear this: a quiet object cannot create this type of structure. Whatever is happening inside 3I Atlas, it is not simple, and it is not behaving like the textbook comets astronomers are used to. A few days later, confirmation came from ESA's JUICE mission, which caught its own angle on the 2 tails. JUICE detected a curved ion tail consistent with strong sublimation, ice turning directly into gas under the sun's heat, and a dust tail stretching millions of miles. Picture that for a moment. A trail so long that Earth could be placed inside it 7 times over. And those were only the structural clues. The chemical ones were even more intriguing. Within the JUICE readings, researchers saw signatures of methanol, cyanide compounds, and sulfur-based molecules. The exotic ices you would expect from the coldest places in the galaxy. These chemicals do not tell you whether 3I Atlas is friendly or hostile, but they do tell you something else. This object formed in temperatures lower than anything in our solar system. Its chemistry belongs to a place older, darker, and colder than the cloud that gave birth to the sun. You do not need the equations behind this. Just imagine it: a visitor carrying the frozen fingerprints of a star long gone. But then came the 3rd update, one that unsettled even seasoned astronomers. JAXA's space-based sensors detected faint X-ray emissions coming from the region around 3I Atlas. The wavelengths match the type produced when charged particles from the solar wind collide with neutral atoms escaping from a comet's surface. Here's the part that made scientists fall silent in interviews. No ground-based observatory, including the Very Large Telescope, had detected any neutral gas at all. To put it simply, the object is emitting X-rays that require gas, but the gas itself has not been seen. This shouldn't happen, and yet it is happening. It's the kind of contradiction that makes researchers return to their data files late at night, wondering if they missed something. And it's the kind of update that reminds you an interstellar visitor is not obligated to follow rules written for comets born in our neighborhood. As the scientific updates poured in, the internet did what the internet always does. Someone posted a dramatic image without context, a long streak across the sky, a caption claiming that 3I Atlas moved 76,600 kilometers in 18 minutes. For a moment, astronomy forums and Facebook groups erupted into speculation. But the actual explanation was much simpler. The streak was only 47 pixels long, and the camera angle exaggerated the movement. It wasn't true velocity. It wasn't proof of acceleration. It wasn't anything mysterious. Still, it spread fast, and thousands of people saw the streak before they ever saw the correction. That's why listening to a full, grounded update like this matters. It keeps your perception anchored. It lets you breathe. It gives you the real story instead of the tension created by misunderstanding. Even with all these anomalies, complex tail structures, surprising chemistry, mysterious X-rays, the orbit data has remained solid. As of now, 3I Atlas is 170 to 178 million miles from Earth, depending on whose model you check. That is far, far beyond any danger zone. Nothing in the physics suggests a risk. Nothing in the trajectory hints at a last-minute deviation. And nothing in the current models gives astronomers any reason to prepare for an emergency. But this distance does not make the story less interesting. It makes it safer to appreciate, and it explains why 3I Atlas has become the most closely monitored object of the year. 1 part science, 1 part mystery, 1 part cosmic theater. Not because it threatens us, but because it does not act like anything we expected. It creates questions faster than researchers can answer them. It forces experts to debate, revisit, and reconsider what they thought they knew. As you sit here listening, you are one of the few people hearing the full chain of updates in a clear, connected narrative. Most people online have only seen fragments. A streak here, a rumor there, a confusing scientific term thrown around without context. You now have all of it. The chemistry, the tails, the X-rays, the distance, the corrections, the truth beneath the noise. And having all of that prepares you for the next part of the journey. Understanding where this visitor began, long before the sun existed, long before Earth formed, long before the conditions for life appeared. To understand why these clues matter, you must travel back to where this visitor came from. To understand why the recent clues matter, you first have to understand what 3I Atlas truly is, not what people think it is, not what headlines suggest it might be, but what its orbit, its speed, and its chemistry say about its birth. Because once you see where this visitor came from, everything else makes a different kind of sense. You begin to realize that this is not just another comet drifting through our neighborhood. This is a guest from somewhere far beyond the sun's reach. A traveler, older than the world beneath your feet. To begin, you have to picture what the word interstellar means in astronomy. It doesn't simply mean far away. It means the object is not bound to the sun in any way. It means the sun's gravity cannot keep it. It means the orbit is hyperbolic, flaring outward instead of curling back into an ellipse. And it means the velocity is high enough to escape the solar system forever. A typical comet swings around the sun like a stone on a string. This one cuts through space like a visitor passing by a porch light, slowing slightly as it approaches, but never enough to be caught. You're looking at something that does not belong here, something that will never return once it leaves. Only 3 objects in human history have shown these interstellar signatures with certainty. The first was 1I Oumuamua, discovered in 2017, a body with no tail, no coma, but a faint acceleration that defied every conventional explanation. Some scientists said it was a shard of a shattered planet. Others said it was a hydrogen iceberg. A few dared to ask if it could be artificial. Whatever the truth, it was the first object to prove that pieces of other star systems sometimes drift through ours. The second was 2I Borisov in 2019, almost the opposite of Oumuamua. It behaved like a perfect textbook comet, complete with a glowing coma, a long tail, and normal sublimation. It looked like the kind of object astronomers were trained to expect, just older and colder. If Oumuamua was the anomaly, Borisov was the control sample. And then came 3I Atlas, stranger than both. Brighter, more active, more structured, and somehow more contradictory. Unlike Oumuamua, it has a dramatic tail. Unlike Borisov, its chemical signals don't line up with what those tails should indicate. Unlike either of them, it exhibits a mix of behaviors that seem borrowed from both categories without fitting neatly into either. It has the structure of a normal comet, but the irregular timing of an abnormal one. It has the chemistry of the most ancient ices, yet displays X-ray emission lines that shouldn't be possible without the gases no one has detected. It behaves like something unfinished, or something sealed, or something carrying internal energy that wakes and sleeps on its own clock. And that is where its age becomes important. Based on its trajectory and the models of how objects drift through the galactic neighborhood, 3I Atlas could have formed around a star system 7 billion years old, meaning it is 2 to 3 billion years older than Earth. Every landscape on our planet, every mountain range, every ocean, every living thing is younger than the rock or ice or metal at the heart of this visitor. This object was already ancient before the first microbes appeared on Earth. It was ancient before the continents formed. It was ancient before the moon existed. If you let that sink in, you begin to feel a quiet shift inside yourself, a kind of awe that pulls you out of daily concerns and reminds you of the scale of time outside human life. You're listening to a story that doesn't just predate human history. It predates the planet. Countless orbits, gravitational slingshots, and stellar crossings shaped this object before Earth was more than dust in a collapsing nebula. And now, for a brief moment, it has wandered close enough for us to study it. Some astronomers call objects like this interstellar chemistry capsules, not because they are dangerous, but because they preserve chemical fingerprints from corners of the galaxy we have never visited. The molecules in 3I Atlas were forged under a different sun. They froze under conditions no longer found in our own system. They carry ratios of elements and isotopes that may never appear in anything native to our neighborhood. In a way, this object is a courier, a messenger, a sample from a long-vanished star. It is not here to harm. It is here to be read. You might imagine it like a package slipping across your doorstep, left by a universe that has been sending messages long before humans learned to look up. Not a message in the dramatic sense. No symbols, no intentions, but a message in chemistry, structure, and age. A reminder that the galaxy is old, restless, and full of wandering fragments from forgotten systems. As you listen, you may feel the pace of the story slow. It isn't accidental. This is the part meant to let you breathe, to let you feel wonder instead of urgency, to create space for the realization that you are alive during one of the rarest moments in human astronomy. Only 3 interstellar visitors have been confirmed in history. You are here for the third. And unlike the first 2, this one is active, visible, confusing, and close enough to teach us something extraordinary. You might even feel a quiet sense of pride. Not loud, not boastful, but personal. You are part of a tiny percentage of people on Earth who actually understand what it means for a comet to be older than every mountain on the planet. Most people will scroll past this story without ever realizing how rare it is. You, on the other hand, are listening. You know the scale. You know the context. You know why this matters. And now that you understand the age and origin of this visitor, you're ready to confront the next question. If its history is ancient, why is its behavior in our solar system so unusual? But if its origin is ancient, its behavior in our solar system is brand new. By now, you understand where 3I Atlas came from and how ancient its journey has been. But to understand why it has become the most closely watched visitor of the decade, you need to see the 4 behaviors that make astronomers stop mid-sentence, stare at their screens, and whisper the same thought. This is not normal. These aren't vague mysteries or dramatic exaggerations. They're concrete, observable contradictions, things that should not happen together if this object were behaving like the kind of comet you've seen in every astronomy book. The first anomaly is simple to understand, but very hard to explain. It is the fact that 3I Atlas has no detectable gas, and yet somehow still has a tail. Ground-based observations from the Very Large Telescope search for the specific chemical fingerprints astronomers expect from comets. They looked for hydroxyl, a breakdown product of water vapor. They looked for cyanide, one of the most common cometary emissions. They found nothing. No OH lines, no CN lines, no obvious volatile gases at all. And yet, when you look at the images, you see a clear coma, a hazy envelope around the nucleus, and a long, structured tail being pushed outward by the sun's radiation. It's not subtle. It's not barely there. It's unmistakable. So you're left with a contradiction. The object appears to be releasing dust and forming a tail, but you can't find the gas that normally carries that dust into space. A basic rule of comet physics says dust doesn't leave the surface by itself. It must be dragged into space by evaporating gas. But here, the gas is missing. This is the kind of contradiction that makes astronomers shake their heads, not in fear, but in confusion. The second anomaly is just as strange. 3I Atlas only began to wake up after perihelion. Before it swung around the sun, it behaved like an asteroid. Quiet, dim, featureless, almost inert. No tail, no jets, no visible activity. If you had seen it then, you would have thought it was a rock. But once it passed perihelion, after reaching the point of closest approach to the sun, it suddenly activated. Jets ignited. Dust streams appeared. The tail extended millions of miles into space. Comets do not behave this way. They normally brighten before reaching the sun, not after leaving it. A comet heating up as it moves away from the sun is like snow melting when the storm has passed and the air is getting colder. It's backward. It's reversed. And this reversal forces astronomers to wonder whether something unusual happened to the object during the weeks it was hidden behind the sun. It was invisible to us for more than a month, and when it emerged, it was transformed. The third anomaly ties directly into the first two and is perhaps the most puzzling of all: the X-ray emissions. JAXA's detectors picked up emission lines corresponding to highly charged carbon, nitrogen, and oxygen, C6, N6, O7. These lines are created when the solar wind collides with neutral atoms evaporating from a comet's surface. You need neutral gas for the charge exchange to occur. But as you've already heard, ground observatories detected no neutral gas whatsoever. That's the contradiction. The object is producing X-rays that require gas, but no gas has been found. That's like hearing an echo without hearing the original sound. Something had to produce the interaction, but the interaction partner is missing. It's one of the most scientifically interesting parts of the entire story. Not because it's dangerous, but because it violates expectations. And then you reach the fourth anomaly, the morphology. This isn't about chemistry or energy. It's about shape. Visible, photographic, undeniable. The structure of 3I Atlas doesn't match any cometary pattern in the last 200 years of recorded images. Some astrophotographers describe a cone-shaped form within the dust. Others highlight the razor-sharp anti-tail, which points back toward the sun instead of away from it, and does so with a precision that makes it stand out even to casual observers. This anti-tail isn't a faint sliver. It's a strong, narrow line, as if the object is shedding material in a direction comets don't normally prioritize. Rai, an amateur astrophotographer who's been tracking 3I Atlas for months, summed it up simply: nothing about this adds up. NASA's commentary team was just as clear. This is unprecedented. When you place all four anomalies side by side, you feel the weight of the mystery. A tail without gas. Activity after perihelion instead of before. X-rays that require neutral gas, but no neutral gas detected. A morphology no comet has shown in centuries of documentation. Any one of these behaviors alone would be enough to raise eyebrows. All four of them together create a picture that can't be explained by the standard model of comet behavior. It would be like watching a bird that swims like a fish, flies like a bat, echoes like a dolphin, and doesn't fit neatly into any category. The mind tries to fit it into a box, but the box keeps expanding. And yet, despite all of this strangeness, there is one thing these anomalies do not suggest: danger. They don't point toward instability. They don't imply unexpected course changes. They don't hint at impact risks. What they point toward is something far more intellectually interesting. The possibility that 3I Atlas is either fragmented, depleted, sealed under a mantle of refractory dust, or shaped by processes we don't yet fully understand. The anomalies make it fascinating. They don't make it threatening. As you listen, you might feel something shift again. Not fear, but a deeper curiosity. You start to understand why this object has been the subject of debates, live streams, late-night conversations, and careful data checks by astronomers who aren't used to being surprised. This isn't a doomsday scenario. This is the rare scientific thrill of encountering a phenomenon that refuses to behave in a tidy way. And all of these contradictions lead you to one question. What happened during the weeks 3I Atlas disappeared behind the sun? So what happened during the weeks we couldn't see it? Before you can understand the three major scenarios scientists are wrestling with today, you have to sit with the strangest chapter of the entire 3I Atlas story. The 42 days when the world lost sight of it. Not because it vanished from space, but because it slipped into a perfect pocket of political noise, bad timing, and the geometry of the solar system. It's the kind of quiet chapter that feels almost cinematic. A visitor heating up, beginning to glow, preparing to reveal its true nature, and then disappearing behind a curtain at the exact moment everyone expected the show to start. The timing began with something very down to earth, a US government shutdown. When that happened, many public outreach channels at NASA were temporarily frozen. The spacecraft kept operating. The instruments kept collecting data. The engineers and scientists kept working behind the scenes. But the steady stream of public updates, the tweets, the graphics, the small contextual notes, slowed dramatically. For casual observers, it created the illusion that the entire astronomy world had gone quiet just as 3I Atlas approached one of the most important phases of its orbit. If you were following the story day by day, you probably felt that slowdown. It wasn't a blackout in space, it was a blackout in communication. Then the second piece of the blackout arrived, this one written by the geometry of 3I Atlas's path. Its orbit carried it into a region of the sky very close to the sun from our perspective on Earth. The glare was overwhelming. Ground-based telescopes, no matter how powerful, couldn't see through that flood of light. Even the best observatories simply couldn't track it without risking their sensors. For nearly 3 weeks, the comet was swallowed by sunlight, not erased, not destroyed, just hidden in a place where our view was impossible. That meant no direct images, no brightness curves, no jet observations, no tail structure updates. It was there, but our instruments were blind. Before the blackout, the expectations had been clear and confident. As it drifted toward perihelion, its brightness was rising. The tail was beginning to form. The anti-tail had appeared, a feature astronomers rarely get to see so clearly. The activity curve looked like a comet preparing for its big moment. Every expert expected 3I Atlas to re-emerge brighter, louder, more dramatic. It was positioned to deliver the kind of show that amateur sky watchers dream about. A surge in luminosity, bold jets, long dust streams, maybe even visible changes to its shape. And then the day of its return came. Instead of a bright object blazing across the detectors, 3I Atlas reappeared as a small point of light. Dim, almost reserved, lacking the active features everyone had predicted. The coma, if it was there at all, was faint. The jets were absent or nearly invisible. The tail, which had stretched millions of miles before perihelion, was muted or missing altogether in several early images. The difference was stark enough that one astronomer described it with a tone of quiet disbelief. We expected a show. Instead, when it came back, it was almost gone. That moment, the moment of underwhelming reappearance, created an immediate whisper across the scientific community and the astronomy forums that had been following the story closely. It wasn't panic. It wasn't fear. It was the subtler, more scientific version of unease. The recognition that something had changed, and no one had seen it happen. For an object that had just begun to heat, sublimate, and release material, the sudden calm didn't fit the pattern. Comets don't usually switch off right after perihelion. If anything, they flare up even more. And that leads to the central question of this entire chapter. What happened while we weren't looking? You aren't being asked to assume conspiracy. You aren't being asked to fear disaster. You're simply being invited to acknowledge the most scientifically intriguing part of the story: a gap in the data large enough for multiple interpretations. A chapter missing from the record, the cosmic equivalent of closing a book mid-sentence and reopening it to find the main character behaving like someone else entirely. It's natural to wonder, what could make a comet that was heating up, brightening, and becoming more active suddenly go quiet? Did 3I Atlas fragment behind the sun, breaking into smaller pieces that are now too faint to show the expected features? Did it run out of volatiles entirely, burning through its internal supply of ices faster than predicted? Or did it undergo some kind of surface transformation, a sealing, a hardening, a sudden crust formation that trapped its remaining gas beneath a skin of dust? These aren't dramatic ideas invented for excitement. They're the exact questions astronomers debated when the first post-blackout images arrived. What makes this chapter so compelling is not that something dangerous happened. It's that something important happened out of view. You're listening to a mystery without fear. A mystery built on missing data rather than looming threats. For a few weeks, the universe simply turned its back, and when it turned around again, the visitor was quieter than expected. As you sit with that thought, you may feel a gentle mixture of curiosity and something like anticipation. This isn't a crisis. It's the kind of gap that has fueled scientific breakthroughs for centuries. You're not hearing a warning. You're hearing an invitation to think, to consider, to follow the possibilities. And those possibilities are exactly where we're going next. If the tail faded, if the jets went silent, if the brightness curve flattened, then astronomers are now faced with three explanations, each of them reasonable, each of them supported by pieces of data, and each of them painting a very different picture of what 3I Atlas truly is. To make sense of that silence, astronomers are now juggling three big possibilities. When scientists face a gap in the data, they do what humans have done for thousands of years. They build possibilities. Not fantasies, not conspiracies, just clear, structured scenarios that let them think through what the evidence could mean. Science hates a blank page. A blank page leaves too much room for imagination and too little space for clarity. So when 3I Atlas went silent for 42 days and returned looking different than expected, astronomers did what they always do in moments like this. They began shaping the possibilities, one scenario at a time, until the picture became focused enough to guide the next steps. The first scenario is fragmentation, the idea that the nucleus cracked into multiple smaller pieces while it was hidden behind the sun. Picture a snowball slowly cracking under stress, then breaking into a handful of pebbles. From far away, those pebbles might still look like a single object. They might reflect light, but they would not behave with the strength or clarity of a solid, intact core. The signs supporting fragmentation are straightforward. When 3I Atlas vanished behind the sun, it was brightening. Its tail was sharpening. Its activity curve was trending upward. But when it returned, it was dimmer. The tail was weaker. The coma was thin or barely visible. A drop in activity like that can happen when a comet breaks apart because the smaller pieces lose the thermal mass needed to continue heating and sublimating. There is less surface area generating energy, less structure, less cohesion. But fragmentation has its weaknesses too. In classic cases of comet breakup, astronomers often see a surge in brightness just before the collapse. First, the pieces shed gas and dust explosively. Then the object fades. With 3I Atlas, that surge wasn't visible before blackout. Nothing about its pre-perihelion behavior suggested an imminent fracture. That doesn't rule fragmentation out, but it makes it harder to embrace without hesitation. Still, it remains one of the top possibilities, especially given the quiet return after perihelion. The second scenario is total volatile depletion. The idea that all the easy-to-evaporate ices on or near the surface were burned off quickly during the intense heat of perihelion. In this scenario, the strong activity seen before blackout could have drained the reservoir of shallow volatiles. The jets and tail could have been powered by ices very close to the surface. Once those were gone, the comet simply had nothing more to give. No gas means no tail. No tail means faint coma. A once active visitor becomes quiet. There are pieces of evidence that align with this idea. The pre-perihelion stage did show strong outgassing. The jets were visible. The dust was lifted. If 3I Atlas had a thin layer of volatiles on top, they could have been consumed quickly. But depletion has weaknesses too. Most comets have deeper ice pockets that continue sublimating long after perihelion. Heat travels inward, warming layers that were previously untouched. Even if the surface ices were depleted, deeper layers should have continued producing gas for weeks, sometimes months. 3 weeks of blackout is not typically enough time to exhaust an entire comet's volatile reservoir. That leaves the third scenario, perhaps the most intriguing of all: mantling. Mantling is the idea that dust and organic materials on the surface melt, fuse, or sinter together during extreme heating, forming a hard crust, an asphalt-like shell that seals the comet's vents. Imagine a handful of dry, carbon-rich grains suddenly cooked by solar radiation and compressed by recondensed material. As the comet rotates, those grains can accumulate and bake into a shell strong enough to trap gas beneath it. From the outside, the object looks dead. But on the inside, pressure can still build. Several clues support the mantling scenario. The rapid heating at perihelion could have created the perfect conditions for a shell to form. The sudden drop in visible activity after blackout makes sense if the vents were sealed. The faint coma on return could be residual dust drifting off the surface, not actual sublimation. And the X-ray emissions, the ones requiring neutral gas, could come from tiny leaks or fractures too small for ground instruments to detect. Mantling explains the silence without requiring the comet to be fully dead. What makes this scenario especially compelling is that it's testable. Later in its journey, when 3I Atlas passes near Jupiter, the massive tidal forces could stress the shell. If the crust cracks, the internal volatiles could vent, reigniting activity. If it doesn't crack, the object may remain quiet. In other words, Jupiter will act like a natural stress test, a diagnostic moment built into the orbit itself. But as appealing as these scenarios are, none of them is perfect. Fragmentation explains the dimming, but not the timing. Depletion explains the silence, but not the lack of deeper sublimation. Mantling explains the trapped behavior, but raises questions about how fast such a crust could form. The truth may be a blend: partial fragmentation combined with partial depletion, wrapped in the beginnings of a mantle. Nature, after all, doesn't always respect neat categories. Still, these three scenarios give you something you didn't have before: a clear menu of possibilities. Not vague speculation, not sensational theories. Just grounded scientific options that fit the limited but intriguing evidence. The picture isn't complete, but the frame is beginning to take shape. And once you understand the frame, the rest of the mystery feels less like chaos and more like a puzzle. You might even feel your mind relaxing as you listen. This isn't a threat. It's a process, a calm, methodical way of approaching something we can't fully see. You don't need to choose a scenario. You just need to understand why astronomers built them and how they'll test them in the weeks and months ahead. And just when you think the mystery is contained within structure and behavior, the chemistry adds an entirely new layer, one that makes the story even stranger. But the chemistry of this object makes the story even stranger. If you want to understand why 3I Atlas feels different from every comet you've casually learned about over the years, you have to look past the tail, the coma, and the orbit. You have to look inside. Not physically, no probe is there, but chemically. Because the chemistry of this interstellar visitor is the part that makes even experienced comet researchers stop, tilt their heads, and say, "All right, that's new." Start with the most surprising detail of all: the ratio of carbon dioxide to water. For a normal comet in our solar system, water is king. Water vapor dominates the plume. Water sublimation drives the jets. Carbon dioxide appears, but usually as a secondary ingredient, more of a supporting character than a lead actor. But in 3I Atlas, that hierarchy is reversed. Instead of water making up the bulk of its volatiles, carbon dioxide accounts for nearly 87%. Water is barely 4%. Statistically speaking, that's a 6.1 sigma deviation from the norm. The kind of extreme outlier that makes researchers check their instruments just to be sure they didn't misread the data. What does that mean? It suggests that 3I Atlas formed in a place with very different temperatures, radiation levels, and chemical conditions than anything inside our solar system. An environment cold enough, dark enough, and ancient enough for carbon dioxide ice to dominate, while water remained scarce or bound in deeper layers. If the interior holds more surprises, we haven't seen them yet. But this one ratio alone hints that you're looking at chemistry shaped under a different sun, or perhaps around no sun at all. And then there's methanol, the molecule that makes scientists smile first and explain later. Methanol isn't dangerous in the context of a comet drifting millions of miles away. What makes it interesting is what it can lead to. Methanol is a precursor to more complex organic molecules, the kind that can stitch themselves into amino acids, sugars, or other prebiotic ingredients under the right conditions. When Avi Loeb and other researchers talk about 3I Atlas as potentially carrying building blocks of life, they're talking about molecules like this. You can picture it as a kind of ancient cocktail, a frozen mixture of carbon-bearing ingredients preserved for billions of years, untouched by warm sunlight or planetary atmospheres. If that sounds nurturing, the next ingredients are the opposite. Hydrogen cyanide and hydrogen sulfide. HCN has a long and grim reputation on Earth as a lethal compound, a chemical with a historical association to poison. Hydrogen sulfide is no gentler, corrosive, toxic, pungent. But in a comet drifting through space, these molecules aren't threats. They're simply part of the raw chemistry of cold environments. They tell a story, not a warning. They're indicators of how the object formed, what materials it collected, and how those materials were processed by cosmic radiation. Still, it's hard not to smile at the coincidence. One molecule associated with the beginnings of life, another associated with ending it. Friendly visitor or serial killer, bottled in the same icy shell. The reality, of course, is far less dramatic and far more scientific. Nothing in these molecules puts Earth at risk. They would disperse harmlessly in space long before they ever approached an environment where they could cause harm. But the symbolism is irresistible, especially when you're listening to a story as big as this one. Then there is the metal puzzle, the nickel without iron. Ground-based spectroscopy has detected nickel emission lines at levels that seem inconsistent with the expected nickel-to-iron ratio found in typical comets. Iron lines, which should appear alongside nickel in predictable proportions, are unusually weak. That imbalance suggests that the environment where 3I Atlas formed experienced different chemical sorting, different radiation exposure, or different temperature gradients than the protoplanetary disk that shaped our own solar system. Some researchers point to exotic formation chemistry, environments where metals separate in ways not commonly seen in the inner solar system. Others consider the possibility of heavy radiation processing over billions of years, altering the structure of the object at a fundamental level. Whatever the explanation, the message is clear. 3I Atlas is chemically foreign in ways that go beyond the simple labels of comet, asteroid, or icy visitor. When you put all of this together, the carbon dioxide dominance, the methanol hinting at ancient organic chemistry, the cyanide and sulfide adding a lethal flavor, the nickel imbalance adding an alien signature, you start to see why this object captures people's imagination so easily. Friendly visitor or serial killer. The truth is that it contains pieces of both personas. Not because it means harm, not because it brings life, but because its chemistry spans a range so broad that it touches both ends of the spectrum. You can think of it like this. The same molecules that nourish are often kin to the molecules that destroy. It's never about the ingredient alone. It's always about the context. On Earth, cyanide is deadly. In space, it's a marker of primitive chemistry. On Earth, methanol can be toxic. In space, it's a stepping stone toward complex organics. The universe doesn't categorize substances as good or bad. It simply arranges them in different environments and lets their roles shift depending on distance, dose, and circumstance. If you're listening to this with a slight smile, you're feeling exactly what this part of the story is meant to evoke. Fascination, amusement, and a sense that you're peeking at a chemistry set far older than your entire planet. And you're probably wondering what different scientists make of all this. Does one group think it's a gentle relic? Does another think it's something harsh and volatile? Do the camps disagree? They do. And the next part of the story is where those disagreements start to get loud. And when chemistry gets this weird, scientists start to disagree loudly. If you've spent the past few months following every update about 3I Atlas, the images, the data, the anomalies, then you've probably noticed something fascinating happening alongside the science itself. The conversation is splitting into three distinct voices. Not warring factions, not conspiracy camps, just three groups of people who see the same set of clues through slightly different lenses. And the closer we get to December 19th, the louder those lenses seem to get. The first voice, and the one that always grabs headlines, belongs to Avi Loeb, Harvard astrophysicist, best-selling author, a scientist who, for better or worse, refuses to treat unconventional explanations as taboo. He has said there is a 30 to 40% probability that 3I Atlas could be non-natural in origin. Not a claim, not a conclusion, a probability. His argument starts with the same type of puzzle pieces that made Oumuamua so controversial. Small hints of non-gravitational acceleration that don't neatly match sublimation models. Morphological features that look too structured or too sharply defined for ordinary cometary physics. And the curious timing of perihelion, which he describes as a convenient moment for a braking maneuver if the object were being controlled. But here is the part of Loeb's position that often gets lost in the noise. He is not standing on a stage shouting alien spacecraft. His actual point is simpler and more disciplined. As he puts it, we should not dismiss that possibility a priori. In other words, don't assume. Don't rule out. Don't close the door before you've even tried to look inside. For a scientist, that's not heresy. That's curiosity. On the opposite side of the spectrum is the mainstream. People like Jason Wright, NASA mission analysts, planetary scientists who have spent their careers studying real comets, real outgassing curves, real jets, real dust tails. Their stance is not combative, it's cautious. Their refrain is the same one Carl Sagan once made famous. Extraordinary claims require extraordinary evidence. And for now, they argue, the evidence simply doesn't rise to that level. Measurement noise can mimic non-gravitational acceleration. Geometry can exaggerate tail asymmetries. Dust jets can look structured under the right viewing angles. Nothing seen so far requires technology or intelligence to explain. Not yet. They're not saying Loeb is wrong. They're saying, slow down. Let the data breathe. Let the instruments speak. Let December 19th and the months after give us something firmer to stand on. Then there's the third voice, the independent analysts, people like Rai, amateur astrophotographers, data synthesizers, forum veterans, skywatchers who read every preprint, every press release, every spectral analysis, and try to stitch them together like a cosmic puzzle. They are not conspiracy theorists. They are not shouting about alien invasions. What they do is ask the kinds of questions busy institutions sometimes don't have time to chase. Why are these anomalies being examined separately? Why does one paper not address the contradictions raised in another? Why does the morphology paper not mention the chemistry paper? They aren't claiming answers. They're poking at the silence between the answers. You might feel yourself relaxing into the conversation as you listen. You're not being told which camp to join. You're not being pushed to defend a position you never wanted to take. You're being invited into the room, a quiet one, late at night, where scientists and thinkers and enthusiasts are all sitting around the same table, looking at the same visitor from another star system and saying, "Well, what do you make of this?" And that's the beauty of this stage of the journey. You don't have to decide who is right. You don't have to align with Harvard or NASA or the independent corners of the astronomy world. You get to enjoy something rarer. The feeling of watching science while it's alive. Before the answers settle, before the arguments fade, before the story becomes simple enough for textbooks. Healthy disagreement is not a flaw in science. It's the engine that keeps it moving. And right now, the engine is humming beautifully. One voice pushes boundaries. One voice grounds the conversation. One voice connects the dots. You get to sit comfortably in the middle, letting each perspective sharpen your curiosity without hijacking your imagination. You get to watch a living debate unfold around an object older than the sun. And beneath all of it, underneath the speculation, the caution, the pattern hunting, is a calm truth. No matter who ends up being right, the next few days will give every camp something they can agree on. More data, better images, cleaner spectra, sharper measurements. And with that comes clarity, the quiet kind that settles arguments not with drama, but with information. You can almost feel the anticipation rising as you listen. If the chemistry is strange enough to split the room, and the behavior is odd enough to raise eyebrows on both sides, then what should you actually pay attention to when December 19th arrives? What signals matter? What would count as normal? What would qualify as unusual? Those are the questions that bring all three voices back together, not in agreement necessarily, but in focus. So with all these voices in play, what should you actually be watching for on December 19th? By now, you've heard enough anomalies, debates, and interpretations to notice something strange. The data about 3I Atlas doesn't always agree with itself. One paper says no gas. Another shows X-ray emissions that require gas. One team describes an elegant cone-shaped structure. Another sees nothing but a faint smudge. If you've been trying to follow along and felt confused, you're not alone. The truth is, even the scientists reading these papers are often just as puzzled. And there's a reason for that. A very simple, very human reason. Right now, dozens of observatories are watching 3I Atlas at the same time. Space telescopes, ground-based telescopes, ultraviolet detectors, infrared cameras, high-resolution optical instruments, radio arrays, and X-ray observatories. Each one is pointed at the same object, but each one is collecting a completely different slice of reality. One sees only dust. One sees only ionized gas. One sees only neutral atoms. One sees only reflected sunlight. One sees only thermal signatures. The universe doesn't hand us one picture. It hands everyone a different piece. And here's the part most people never hear. Nobody is responsible for stitching the whole puzzle together. Each team is granted observation time only for the specific scientific goals they proposed months earlier. A spectroscopy team cannot suddenly pivot to deep imaging. A wide-field imaging team cannot suddenly ask for X-ray time. Telescope time is approved through long peer review cycles, and every group is studying their own tiny window, not the full story. That's how you end up with contradictions like these. One group reports no gas. Another group detects X-ray lines that absolutely require neutral gas. A third group sees a cone-shaped anti-tail pointing toward the sun. None of them are wrong. They're just looking at different layers of the same object with different tools, at different times, through slightly different slices of reality. Then there is the publication process itself. Scientific papers are slow. They move through reviewers, edits, revisions, and formatting. A single paper might take 2, 3, sometimes 6 months to become public. But 3i Atlas is changing week by week. By the time a paper is published, the comet may have shifted into a new phase entirely. The data was never wrong. It was simply about an earlier state of the object. And because there's no centralized system that blends all telescope data together in real time, everything feels scattered, fragmented, incomplete. If you've ever read 1 or 2 articles about 3i Atlas and felt like the story doesn't add up, that's not a failure on your part. It's a feature of astronomy itself. Data doesn't arrive as a unified narrative. It arrives as snapshots taken from different angles, at different wavelengths, through different instruments, by different teams who may never even speak to each other. This creates a peculiar kind of confusion, not the anxious kind, but the kind that makes you lean in a little closer. You aren't watching a polished documentary. You're watching science in the middle of a live performance, each instrument playing its own melody. Science is not a single voice. It's a choir singing slightly out of sync. And that's where independent analysts come in. People like Rye and thousands of others who spend their nights reading every preprint, comparing every graph, lining up every timestamp, and asking the questions that fall through the cracks. They're not trying to conjure conspiracies. They're asking, are we missing a bigger picture? Is anyone merging these data streams? Do these anomalies become clearer when you place them side by side? They serve as the connective tissue in a system that isn't built to be connected. When you understand this, something important happens. The confusion becomes less stressful. You stop interpreting contradictions as signs of danger or secrecy. Instead, you see them as the natural state of a field trying to assemble a picture from mismatched pieces. Astronomy has always been this way. It's a discipline built on glimpses. A flash here, a spectrum there. A faint trace of gas on one wavelength, but not on another. The universe does not owe us a fast answer. And the less complete our data is, the more our imagination tries to fill the void. That's human nature. It doesn't mean something is wrong. It means we care. It means we're curious. It means we're paying attention to every clue. And now that you understand why the data seems inconsistent, and why that inconsistency is normal, you're ready for the part everyone is waiting for. The simple, grounded checklist of exactly what to watch for on December 19th. Not as a scientist, not as a skeptic or a believer, just as someone who wants to understand what matters. So let's talk about December 19th, the day everyone is waiting for. There's a reason December 19th has been circled on calendars across observatories, astronomy forums, and living rooms full of quiet sky watchers who check updates before bed. It's not because anything dangerous is expected. It's because this is the night 3i Atlas comes closest to Earth. Not close in the way movies like to imagine, but close enough for our instruments to see it more clearly than at any other point in its journey. It's the moment where the blurry pixels sharpen, where tail structures become easier to confirm, where brightness curves become more reliable, where jets, if they exist, have their best chance of showing up. What matters most about December 19th is not the distance. It's the resolution. When an object is millions of miles away, clarity is a rare luxury. On this night, clarity is finally possible. You will see something because the instruments will see more. But that something may be subtle. It may be quiet. It may be nothing more dramatic than a small change in brightness. And that's okay. Normal even. So instead of thinking about December 19th as a movie moment, think of it as a diagnostic snapshot, a medical checkup for a visitor from another star system. And like any checkup, there are a few clear outcomes that astronomers expect. 3, to be precise. 3 scenarios that cover the full range of what could realistically happen. None of them involve danger. All of them involve clarity. The first is the silent scenario. Nothing brightens, nothing moves, nothing changes. The object appears in the images as a quiet point of light, maybe with a faint, almost ghost-like haze around it, maybe with no visible coma at all. No jets, no tail, no flare, just stillness. What would that mean? It would suggest that one of the earlier explanations, mantling or depletion, is probably correct. A sealed surface would suppress sublimation. A depleted reservoir of shallow ices would leave the object with nothing left to eject. Fragmentation into tiny pieces could also produce a quiet profile because smaller fragments don't generate the same visible activity as a solid nucleus. But here's what it wouldn't mean. It wouldn't mean the object is dead. It wouldn't mean it vanished in a dangerous way. It wouldn't mean something went wrong. Silence is completely normal for an interstellar body. Oumuamua showed no tail at all. Borisov showed one. Interstellar visitors have no obligation to behave consistently. Quiet is not ominous. Quiet is informative. The second possibility is the active scenario. A sudden brightening, a short-lived flare, a fresh jet appearing on camera, a tail lengthening, a coma thickening, something visibly alive. If that happens, it would mean the crust, assuming it formed, finally cracked. Perhaps deeper layers of ice are warming enough to release fresh material. Perhaps the nucleus rotated to expose a vent. Perhaps pressure built beneath the mantle until something gave way. In other words, a reawakening. If that happens, it is not a sign of threat. Outgassing cannot steer an object toward Earth. A jet cannot pivot an interstellar visitor into a new trajectory. The physics doesn't allow that. Outgassing produces tiny, gentle accelerations, like the breath of a sleeping creature. They can adjust rotation rates. They can shift a brightness curve. But they cannot bend a path millions of miles wide. As the NASA Planetary Defense Coordination Office puts it, outgassing can't steer a comet into danger. That's not how physics works. So if 3I Atlas brightens suddenly, it means learning, not risk. It means there is more material beneath the surface than expected. It means the story isn't finished. Then there is the third scenario, the geometry and data scenario. This is the one casual observers rarely think about, but professional astronomers quietly expect. In this outcome, you will see images online and think, nothing happened. The photos will look flat. unchanged, plain, but the real action will be invisible, buried in the spectra, hidden in the X-ray lines, subtle in the polarization data, locked inside thermal signatures. While the public sees a handful of still frames, instruments like Hubble, JWST, JUICE, SOHO, NEOWISE, and dozens of ground-based facilities will be collecting mountains of high-value information. They will be measuring the chemistry of the coma, the temperature gradient of the nucleus, the dust-to-gas ratio, the ionization state, the structure of any existing jets, the speed of outflowing material, the spin rate of the core. In this scenario, the images aren't the story. The instruments are. It doesn't mean nothing happened. It means the most important things happened where regular cameras cannot see. And that leads to a natural question, one that almost every listener has silently asked in the back of their mind. What should I personally expect? Not as a scientist, not as an expert, just as someone curious about this moment. The answer is softer than you might expect. Expect clarity, not danger. Expect a night where the mystery shrinks, not grows. Expect a handful of simple things to look for, not as a test, not as a stress point, but as a way to appreciate the journey. 4 clues to be exact. The first is the presence or absence of a tail, even a faint one, even a wispy one. A tail tells you that sublimation is still happening, even at low levels. The second is brightness. Does it stay stable, rise slightly, fall? Each of those outcomes tells a different story about the surface and its depth. The third is activity. Jets, mini flares, small asymmetries in the coma. These don't show danger. They show life, chemical life, thermal life, the kind of life comets display when sunlight reaches the right place at the right time. The fourth is timing. When do observatories release their findings? Which instruments speak first? How do the data streams converge? The story of a comet is told as much through time as through images. And beneath all of that is a deeper, quieter truth. The universe is not trying to frighten you. It is not leaning toward Earth with a threat. It is not hiding a twist or a surprise meant to unsettle you. It is simply behaving as it does, slowly, silently, elegantly, offering you a glimpse of something rare, a visitor from another star system that your species will see once and only once in your entire civilization's timeline. The question worth asking is not, will it harm us? That answer has already been given clearly. No. The real question is, what can we learn from a traveler older than every mountain on this planet? What does it tell us about chemistry beyond the sun's influence? About ice forged in ancient places? About radiation environments we've never witnessed? About pathways through the galaxy no probe from Earth has ever followed? Learning is the gift. Clarity is the destination. December 19th is the moment the story sharpens. And once that moment passes, the next chapter waits just ahead. A chapter where 3I Atlas will face the gravitational giant that has reshaped countless icy objects before it. And just 3 months later, 3I Atlas will face its next test. Jupiter. As much anticipation as December 19th carries, there is another date quietly waiting on the horizon. A moment even more revealing, even more decisive, and in many ways, far more scientifically valuable. March of 2026. The night 3I Atlas passes near Jupiter. If December is the moment of clarity, then March is the moment of truth. Because Jupiter, more than any planet in our solar system, has the power to expose the inner structure of an interstellar visitor in a way no telescope, no spectrum, and no brightness curve ever could. Jupiter is not gentle. Jupiter is not subtle. Jupiter is gravity, naked, immense, and unfiltered. And gravity, when applied to a fragile object from another star system, becomes a kind of natural laboratory. Start with something simple and intuitive. Jupiter has the strongest gravitational pull of any planet in the solar system. Only the Sun exceeds it. When a small body passes near Jupiter, that gravity doesn't just tug. It stretches. It squeezes. It tests the object's internal cohesion. Astronomers call this tidal force, but you can think of it as the same force that lifts Earth's oceans into tides, scaled up by orders of magnitude. Those tidal forces can do 4 things to a comet-like body. They can pull it slightly out of shape. They can crack a mantle. They can expose deeper layers of ice that were previously locked away. Or they can do absolutely nothing because the object is tougher than expected. In every case, the outcome tells you something fundamental about what the object is made of and how it has survived its long journey through interstellar space. So what might happen in March? The first possibility is that the mantle cracks. If 3I Atlas really did seal itself during perihelion, hardening its outer layer into an asphalt-like crust, then Jupiter's gravity could be the force that finally breaks that shell. If it cracks, 3I Atlas could brighten again. New jets could appear. A fresh tail could form. Activity could return, not because the object was dormant, but because the pressure inside finally found an escape route. If this happens, it would be the strongest evidence yet that the mantling scenario from earlier in the story is correct. The second possibility is depletion confirmed. Imagine the object passing Jupiter and doing absolutely nothing. No brightening, no jets, no change in behavior at all. In that case, the simplest explanation becomes the most likely. 3I Atlas burned through all its shallow volatiles earlier in the journey, and there is no deeper reservoir for Jupiter to reveal. That wouldn't make it dead. It would make it spent, a traveler with nothing left to give. A quiet ancient shard of ice and dust that has been drifting for billions of years. The third possibility is fragmentation, not because of weakness, but because of the immense stress Jupiter can exert. If the nucleus has internal fractures or fragile layering, Jupiter's tidal forces could pull it apart. In deep exposure images, that would appear as a cluster of small fragments trailing behind the original object. Not a catastrophe, not a danger, but an unveiling. A chance to see the internal architecture that has been hidden since before the Earth existed. And here's the most important part. None of these possibilities involve danger. 3I Atlas will not hit Jupiter. It will not spiral into the planet. It will not ricochet through the solar system. It will pass at a distance that is large, safe, and scientifically perfect. Close enough for stress, far enough for stability. It is the astronomical equivalent of a close inspection, not a collision. That's why astronomers are quietly more excited about March than December. December is observation. March is diagnosis. December tells us what the surface is doing. March tells us what the interior is made of. You can almost picture it. 3I Atlas, drifting past the solar system's giant guardian, a tiny interstellar object crossing the gravitational field of a world 11 times wider than Earth. A grain of ancient ice brushing past a planet so powerful it has shaped the entire architecture of our cosmic neighborhood. There's something poetic about it. A visitor from another star meeting the gatekeeper of our own. And within that poetry lies a simple scientific truth. Nature reveals itself under pressure, and Jupiter is pressure. If you're listening to this with a quiet sense of anticipation, that's exactly the feeling this moment is meant to evoke. Not fear, not urgency, just the recognition that the story isn't finished. It's still unfolding, still offering clues, still inviting you to follow along. And the best part? We will return to this moment when March arrives. We'll come back to see which scenario survived the journey. We'll check whether the mantle cracked, whether the volatiles were truly gone, whether the nucleus held its shape or yielded to Jupiter's pull. March will answer questions, December cannot. But tonight, none of this is a threat to you. Out there in the dark, far beyond your window, beyond your neighborhood, beyond the thin blue shell of the atmosphere, a small interstellar visitor is drifting quietly through the night. If you could see it now, you wouldn't see danger. You wouldn't see threat. You would see a patient point of light, gliding in a silence older than anything on Earth. No urgency, no intention, just motion. Slow, steady, ancient. 3I Atlas is already slipping farther away, taking with it the chemistry it has carried for billions of years. Carbon dioxide frozen in patterns no comet in our solar system shares. Methanol that whispers of prebiotic chemistry. Cyanide and sulfide that once sounded frightening, until you realize they say more about distant formation zones than about any threat to our world. Nickel lines without iron. A mantle that may or may not be sealed. A set of anomalies that confused the instruments but never endangered the Earth. All of it drifting away now, like a lantern moving across an empty field. And as you let your mind soften, you can trace its journey one last time. It came from a place colder and older than anything you have known. Perhaps from a star long gone. Perhaps from a system that never formed planets at all. It crossed the void with a tail that sometimes appeared and sometimes didn't. It carried X-rays that shouldn't have been possible without gas, and gas signatures that sometimes seemed to disappear. It went silent for 42 days, slipped behind the glare of the sun, and returned quieter than anyone expected. It gave you 3 scenarios, 3 debates, 3 chapters of a story the universe rarely lets humans witness. And soon, it will be gone. Not lost, not destroyed, simply returned to the darkness it came from. You were here for the brief moment it passed near our world. You were one of the few people out of 8 billion who followed the details closely enough to understand what was truly happening. No panic, no sensational headline, just the real story, the science, the mystery, the beauty. You know more than most people ever will about a traveler that may not return for millions of years, if it ever returns at all. That knowledge carries a quiet kind of privilege. While everyone else rushes between meetings, inboxes, deadlines, and small daily storms, you're ending your day with a wider horizon. You have held in your hands, even if only for a few minutes, the sense of scale that makes everything else feel a little lighter. a little smaller, a little easier to breathe through. Because the true meaning of Three-Eye Atlas was never fear. It was perspective. A reminder that the universe flows with a calm older than any worry, any appointment, any noise. The cosmos is vast, unhurried, and serene. Objects like Three-Eye Atlas pass by not to warn us, but to remind us how much more there is beyond the edges of our busy, narrow fields of view. The things we fear most are often the things we do not yet understand. But understanding is its own kind of light, soft, gentle, steady. And tonight, that light is enough. It's the kind of understanding that settles into your shoulders, slows your breathing, loosens the tight corners of your day. Knowledge doesn't keep you awake. The right kind of knowledge helps you rest. So let the visitor drift. Let it fade into the night like a page of old cosmic history turning softly in the wind. You don't need to follow it into the dark. You've learned what matters. You've seen how scientists wrestle with the unknown. You've watched a debate play out without picking sides. You've felt curiosity transform into clarity, and clarity transform into something quieter, something like peace. Right now, Three-Eye Atlas is moving farther from Earth, farther from the sun, farther into a silence it has known for longer than our planet has had oceans. And as it goes, your world remains exactly as it is, stable, steady, safe. The universe is not rushing toward you. Nothing in the night sky is leaning closer with intent. Everything is drifting in its place, following physics older than memory. And you are part of that calm tonight. So breathe a little deeper. Let your shoulders drop. Let your thoughts slow to the same pace as that distant visitor slipping through the dark. You are safe. The universe is quiet tonight. And in that quiet, there is room for rest. When you wake up tomorrow, the visitor will still be there. But tonight, you can rest.